Data mining process. So the data mining is in the entire process, really from grabbing the raw data all the way to getting the knowledge from that data. What questions can we answer from that data? Usually the patterns section is where we think of data mining as far as the data mining techniques. We'll call them the data mining techniques, such as classification, frequent pattern analysis, and clustering. And it's still important to do all the data manipulation beforehand, because if our data isn't good, we will get false patterns and false knowledge that is not actually representative of the data. So all this lead up work before we do the data mining is very critical to the data mining process. We start with the raw data, and that could be from multiple sources that we then work with to bring together. So we integrate the data and we'll do data cleaning. So things like fixing errors, we might have to fill in empty fields or perhaps delete them or ignore them depending on the situation. We'll do some normalization. So we don't want some fields being ranked from 0 to 100 and others between 0 and 5 without being normalized. Otherwise, the 0 through 100 would take over and dominate over the 0 through 5. So we do this normalization of the data. And then a feature selection and reduction so that we're working with features that are going to help us answer these questions. And with our transform data, we do the pattern discovery. There's a bunch of different data mining techniques that we can do to determine the knowledge that we can gain from the data. And then we can visualize and interpret the patterns that we gain. So with data mining and business intelligence, this is a great diagram to show the data sources down at the bottom, where we might have data coming from files, Excel, from a database. You just can get your data from a bunch of different sources. It could be streaming data as well, which is kind of on the forefront of data mining research right now. And this is where typically a DBA, database administrator, might be working. For data mining, we take our data and pre-process it and integrate it and put it into data warehouses. So we keep it separate from the original raw data, especially something like transaction data that's still being happening. So like in a store, if you're keeping track of each sale, we don't want to be working from there and changing values. So we take the data and put it into a separate place, which is the data warehouse, where we do our manipulation and aggregations and such. One step that we're going to do is data exploration. So we're going to look at the data and try to determine what can we see just from basic exploration of the data. Maybe some quick statistics of the data, maybe some quick graphs of the data to give us a feel for where patterns may be or where we need to explore and to find some more information. Then the data mining is where we do our information discovery and the data mining processes. And then we can visualize our data. And then the end user ends up at the decision-making process up at the top. So there's multiple dimensional views of data mining, and the four that we'll look at are data, knowledge, method, and application. For the data, we're looking at the kinds of data to be mined. And ask yourself, what kind of data do you have or that you can get? Because perhaps you have a data set on taxis, and maybe you can also get weather data and incorporate that. What type of data does it contain? So we want to look at text. Is it image, video, audio, or graph type data? It's perhaps static data, one-time snapshot, or is it continuous with timestamp locations? Or streaming. So do I need to get the data from multiple places? You might be taking and integrating with taxi information, the traffic data that you can get from another source, and then weather data and air quality data, as well as an events data set. So you want to identify those data sets and then merge them to use. That's our data view. For knowledge, this is the kinds of knowledge to be discovered. What do you want to learn from the data? What knowledge are you trying to gain from the data? So essentially, it's like, what question are you trying to ask? I'm trying to figure out, for example, when the air quality is really bad, is it based on the weather or the traffic affecting it, for example? So knowledge is about the what do you want to answer? Like, what question do you want answered? What would you like to find out? What, for example, what items are typically bought together? Or if they just bought a printer, what are they going to want to buy next so that I can either prep the store, so I put things that may be purchased together in the same location. I might do targeted ads. So that's all the application aspect from based on the knowledge that we can gain. The method is the techniques that we're going to use. So how do we answer that question? And so this could range from whether we're doing clustering, so we're looking for similar people, like in the recommendation system. Could be classification. We want to determine for each purchase, is it fraud or is it not? Is it just a regular normal transaction? So given the history on the users of these types of purchases, is this one an anomaly, one of the outliers? So the method are the different techniques that we're going to look at, like clustering, classification, frequent pattern analysis, and outlier analysis, to try to gain the knowledge that we want the question answered. An application is the kinds of applications adapted. So how do we apply the knowledge? How do we apply this in different fields? So for the data to be mined in more depth here, we've got the data can come from all these different sources, and this is just a simple listing. We have databases where we can get transactional data, like from Target or Walmart, data warehouse. So CU campuses, for example, would have a data warehouse of all the different campuses together. So we, in data mining, we work and put our data in a data warehouse. And the data that you grab might already be in other data warehouses. Transactional data is for the market basket analysis. Sequence is when we are looking at a prereq. So someone buys printer, what are they likely to buy next? So eventually the ink was going to run out. So they're going to come back and want more ink. They might want to buy more paper. So that's sequence analysis. Data streams, social media is a big one. So Twitter and Facebook with that constant stream, real-time data coming in, also from sensors. Spatial temporal, cell phones with location time, looking for change. We have time series, temperature readings and time, the location, stocks over time. Web, multimedia in the web, so you got multiple different data types. You got links in the web, graphs, especially in social networks and information networks, we'll find a lot with graphs, and you can find who the social leader is or who brings everyone together, who an influencer is, who's really making waves in there and influencing their group. For knowledge to be mined, we can look at all these different things. We're going to go into more detail, so starting with characterization, and we're going to be covering a bunch of these now, and then we'll talk about each one of these in depth in separate chapters. So the first one for knowledge to be mined, this is the similarity and dissimilarity. So similarity is where we're trying to do a characterization. So we're looking for similarity. So basically customers, as an example, customers who spent $1,000 a year. Who are they? So perhaps this is Walmart or Target, and these are customers who tend to spend $1,000 every year. They tend to be age 40 to 50. They tend to be employed. They tend to have good credit ratings. All right, and that can be different based on which company you're working or looking at. Amazon, online Amazon might have a different characterization for their particular customers. All right, but then you know who your target market is. For discrimination, we're differentiating frequent versus infrequent customers. And so similar to what we did with the characterization, we're also looking at, well, who are frequent customers or who are the infrequent customers? Is there a differentiation based on age, education, whether they're employed or not? Dry versus wet regions, etc. So with frequent patterns, we're going to spend 2 chapters on the frequent patterns. So what items are frequently purchased together in your Walmart? So that would be an example of a frequent pattern. What is frequently bought together? And so we can have frequent item sets. So these milk and bread were frequently bought together. And beer and diapers is the funny one. If you've heard about this in data mining, that when they did the data mining, they weren't expecting this, but they did find that beer and diapers were frequently bought together. And there's more in depth to the story about it being Fridays at 6 p.m. I guess maybe perhaps someone was coming home from work and was asked to pick up some diapers for the weekend so you don't have to go back out again. And then they were also going to buy beer because it was Friday night. So the data mining doesn't give us all that backstory. All it tells us is beer and diapers frequently bought together. All right, you got to do a lot more digging to find out more details about if it's Friday or not, or 6 p.m. and to 9 p.m. or whatever those details are. So that's a frequent item set, things that were bought together. And that helps us, that knowledge, we can apply that knowledge in the application by perhaps placing milk and bread in the same location. So, or some stores like to put them on opposite sides of the store, because if you need milk and you need bread, that would force you to walk through the entire store and perhaps find something else you might pick up to purchase as well. Frequent sequences, so this is where you buy one thing and then later you buy something else. So typically in America, we do the dinner and then a movie on a date. For market basket analysis, we may look at the printer. You buy a printer and then you have to buy toner or ink later, maybe a month or two down the road. That would be a frequent sequence that happens. That would also be that Target example where Target figured out that the teenager was pregnant. It was based on both frequent item sets, what was bought, as well as the sequence. There's a sequence when you find out you're pregnant that you would, steps that you would go through of things that you would purchase, whether it was folic acid, whether baby book names, perhaps a bright blue rug. And then frequent structures, so huge graphs, and we can identify substructures that occur frequently. So you might have something like a star structure where I'm talking to everyone as the leader versus the peers. So that's another example. So these are all examples of frequent patterns. Now for associations, we're going to spend more time on this. This is an introduction to the association analysis. And the idea behind this is that X is our customer. So X could be a person, we might have characteristics like their age is between the age of 31 and 40, their income is mid-range, they're employed, and they have a degree. So X could be a series of different information. So X is our customer. So here we've got buys, if a person buys milk, what is the probability then that they would also buy bread? We have a support and confidence on this. So our association rule is this first line. Buys, X buys milk. What's the chance that it would also, that same customer would buy bread? And we have a support and confidence on that. Support is the co-occurrence. How many times the items appear in the database together? So the support, out of all transactions, how many have bought both milk and bread? For confidence, we're looking at a directive probability. If A happens, that B also happens. So we start with only customers who bought bread. What is the chance that milk also was purchased? So we have our percentages here. We have a minimal support and a minimal confidence here that we can work with. So minimum value, a threshold for the frequent. What does it mean for it to be frequent? So you have a minimum support value that it would have to be with a minimum confidence threshold to hit before we call it frequent. And we look at it as a pattern, a frequent pattern. Now with our classification and prediction, for classification specifically, we have a label that we're trying to classify to. So when new data comes in, this is an example where we have animals. So if we had some DNA or something and we wanted to classify, in our data set, we have a bunch of information about these different types of animals, and we can classify, we know it's classified as mammals, insects, birds, or fish, or whatnot. So that would be a classification type problem. where we know labels in our data set and our training data set, and that's what we're trying to do, is classify the new data to one of those classification labels. For prediction, it's working from numerical data, and so we're predicting, we don't have a specific label for it, we're looking to predict an approximate value. So something like the stock market, you don't classify it, you're trying to predict what the value would be approximately. So with classification and prediction, we're trying to find a model. We build up a model to do the classification and prediction for us. And so we work on training data set. We take our very large data set and we'll use a portion of it as training, and then we will test on another portion of that data set that we have with the class labels. And we'll get into more depth with that later. And then what the idea is, if we're testing on a portion of that data set, we can get a feel for how accurate our model is. And so we can try to build better models that are more accurate working on this training and testing data sets. And then the classification is how we know whether or not it was accurate, whether it was correct, and when we're building that model. So essentially this is machine learning that is trying to figure out the best model to do the classification. There are many methods for classification and prediction. We could use if-then rules, which is simple, pretty straightforward decision based on an if-then rule. Decision tree, where you start at the root, we create and figure out what attribute to split on. And so, for example, if first check on the age and then check on their income level, and then we can determine whether or not they're going to make a purchase or not. Neural network, it's a little bit more complex. So here we've got a network that's being created, and it's not as obvious on how to interpret it because a lot of it's behind the scenes. It's creating these invisible network to do the classification. And so again, it's machine learning, and it's trying to build out a model that works the best. We also have logistical regression and support vector machines, and we'll see all of these in a little bit more detail as we go. And again, numerical prediction, stocks or predicting revenue, and next year forecasting the revenue. This is a continuous value, so it's a numerical continuous value. So we don't have class labels, we're just trying to predict the value of where it's going to end up. For clustering, this is considered unsupervised learning. Here we don't have a class label. So we're not trying to label it whether they bought a computer or not, or whether they're pregnant or not. We're just trying to group data that are similar. And so we create these clusters based on similarity. And so referring to the similarity distance functions, we want to maximize how close each of the data items are within a cluster, because that means they're very similar. And we want each cluster to be as far as possible from another cluster. That's the between clusters, we want them to be as far apart as possible. With the trend and deviation, so for knowledge that can be gained, we can look at trend and deviations. And so trends, Google has this really cool trends that you can go to and play with and see different trends and do graphs based on different trends. So you can look up the Oscars and how often they happen, or even Facebook or baseball statistics, and track them in there. So trends is over time what we're looking at. Some years are more interest. There might be a pattern. So something like the Golden Globes, there's an annual pattern. So every year it becomes interesting as far as social media and people talking about it. And then it dies off again until it gets to around to the following year. So that's what you can see in the data, and that would be our trend that we're looking at. And any deviations, we can use that as interesting to find out, well, what happened. Outlier analysis, this is where a data object does not comply with the general behavior of the rest of the data. And so it's considered to be an outlier. Now, sometimes outliers are annoying because they're noise or errors, and it's more of an exception, and we want to either get rid of it because it's skewing our data, but sometimes we actually want to know about the outliers. So the example in fraud detection, that's where we want to find the outliers because it's not a normal purchase. It's a fraudulent purchase. Someone stole the credit card, and so we want to be able to stop the credit card right away. So we want to be aware of any outliers immediately. It's not the normal trend for that person, for their purchases. And so we can do something about that. So marketing analysis. Here we have different data sources such as credit card transactions, club cards, customer calls, lifestyle studies, a variety of different sources that we can get for the data. And then we can use target marketing. So find customers with similar patterns and determine the customer purchasing patterns. So if you know there's another customer that's very much like this one individual, you can, and this customer ended up purchasing a big screen TV next, well then if you're very similar to this one other customer, that might be where you might want to target the ads. Hey, some big screen TVs, or they're really just into tech and they want to be at the forefront of the wearables, whether they're watches or whatnot. And so you you can target your ads based on what you know about your customer. And so that's where the types of customers buy what products, we can end up really customizing our advertising to those particular customers based on other customers. So we're looking for patterns, and then we're looking for similarities between the customers. So we're doing two different techniques there. So what factors attract new customers? And so the application of determining that, so when you get new customers, what was it that attracted them? Then we can set up by giving out free samples or discounted products to bring in other new customers. For structure and network analysis, we've got graph mining, so finding frequent subgraphs. So in chemical compounds, you'll see a lot of graphs. With XML, if you've worked with any XML, the tree structure that gets set up there, or even HTML, there's substructures within web fragments. So we can mine those particular graphs, or we can also look at information network analysis like social networks, where actors are the objects and nodes and the relationships are the edges between them. And so besides Twitter and Facebook, obvious social networks, you can also find things like author networks in computer science and the links between papers and what those connections are, for example. Link mining, whether it's people following each other. So what's interesting is Twitter would be a one-way directed graph from your data structures background, because with Twitter you can follow, but they don't have to follow back. Whereas Facebook, it's got to be a mutual follow, so you don't have or need a directed graph, because if you are friends on Facebook, then it's bidirectional by default. And then web mining. So web has a lot of information, huge information network. And then with PageRank was Google's initial start, is setting up how to rank pages based on influence and what their connection was within the network. And so the analysis of web information networks, the web community discovery, you can use for opinion mining, usage mining, lots of areas to mine in the web. Now with the interestingness, so are the patterns interesting? We want to go back and always ensure that the patterns that we're looking for, they're interesting. And we define interesting as being valid, so we want it to be valid on new test data. So some kind of certainty that this pattern also works on the new data that we get, not just on the training set that we've been working with. And novel, so it's got to be something new, something that isn't already known. That's what makes the pattern interesting. And potentially useful. It doesn't make sense to find patterns just for the sake of finding patterns if there's nothing we can do with it and it's not something we'd want to make use of. So we're looking for the interesting ones, the ones that are useful. and ultimately understandable by humans. So we want to be able to explain why or make sense of the decision that's made. So when we end up doing the data mining methodologies, we'll see with classification, if we're doing a decision tree, we can see when we create the model of the decision tree, it will let us know what we split on the first at the root of the tree and then for each subsequent level. And so that's very understandable for humans. When we're working with something like a neural network, there's a lot of hidden layers and such, and that's all in that machine learning area. And sometimes it can be not really interpretable as far as how it came to its decision making process to build out that model. And so ultimately, the pattern, we want to make sure it's something that would be understandable and we can digest. Are all my knowledge interesting? One can mine tons of different patterns. So we really do want to find ones that make sense, ones that are interesting patterns. They're novel, they're useful. So some may fit only in certain dimensional space, like in time or location. And so that's one thing we will address. And then some may not be representative. It may be a transient thing, like a quick fad or something. So it's a pattern, but it was only a pattern in a very limited amount of time, or it's only a pattern in the past. It's not something that we can apply in the future. So objective measures, we're using the support and confidence to help us in determining our frequent patterns, and subjective measures, and we'll look at completeness versus and exclusiveness. So completeness, you found this pattern. Did you find them all? That is the question for completeness. We found some patterns, but did we find them all? Find all the categories in this data set. So how complete is our analysis? It's one way to guarantee the other patterns are not interesting. Or not looking at those other patterns, the exclusiveness. So the techniques used, we are looking at data intensive. We've got the data warehouse, which is the OLAP. We're going to use online analytical processing and machine learning and statistics. And so statistics, will look at probability-based methods for the statistics. And pattern recognition is key. That's a lot of what we're going to be focusing on. The visualization. We use visualization both for exploring the data, so just trying to take a look and get a sense for what the data is and what it has in there, where patterns may possibly lie, as well as understanding the results. So there are two times that we're going to look at the visualization of the data, and then high performance and other techniques. The applications, this has been adapted to so many different areas. So with retail, you can have targeted marketing. So you know the customer's interested in high tech and being on the cutting edge, then target your ads towards wearables and the latest, greatest new high three-dimensional TV and such. Also product placement. So if you have a brick and mortar store, what items would you want placed together in the store versus on opposite ends of the store? So depending on what it is you're trying to achieve. For telecommunications, banking with fraud activity for credit cards, whether you put a hold on the card or not, that's with fraud analysis. Bio data mining, so classifying diseases is a big one. Stock market analysis, of course, a lot of people try to predict stocks and try to make money that way. But also predicting sales or even an athlete's progress as they move forward. Text mining, there's things like sentiment analysis. What's the general gist of what people are saying about a particular topic? Looking at web mining, such as social influencers and who's at the social hub. So with the applications, the adaptation of this, differentiating as well the knowledge gain versus the application. So remember, the knowledge gained is answering the question, like what question can we get from this data? What can we answer? What can we find out? And then that's the knowledge that we gain. Oh, we found out that beer and diapers are frequently bought together. All right, so that's knowledge gain. Then the application of that knowledge would be the targeted marketing. All right, so we're going to market to people. Hey, if you're buying diapers, you probably want beer and things like that. So, targeted marketing, product placement. This is all the application of that knowledge. So, given that knowledge, what would you do to apply that knowledge?